And one last video for this learning target is just being able to convert between radians and degrees and back and forth. It's not, you don't want to rely on it. It can be pretty easy because degrees are something we already know and already maybe feel a little more confident in. It can be really tempting to always rely on putting everything back into degrees from radians. And it's an important skill to know how to do that, but you don't want to rely on this. Okay, you don't want to use this for graphing. Because once you get to pre-calc, radians become our primary thing that we use. Until we kind of get to the physics aspect of pre-calc, all we use is radians. So it's important that we put our best foot forward to become familiar with them, but also have this skill of being to convert between them if we need to. So all we do is it kind of relies on the fact that we know that 180 degrees is equal to pi. Because we know that, we can use that fact to take anything, if we have something in degrees, if we take it and we multiply by pi over 180, it's going to come out in radians. And if we have something in radians and we multiply by 180 over pi, it's going to come out in degrees. So this is pretty straightforward. It's pretty simple. A lot of it is calculator work, but we do always have to be careful with typing pi into our calculator and making sure that, we don't do that, because then it will give us an irrational number. So again, I don't even know why I have both of these slides, but it's the same. These are the rules we have to know to go back and forth between them. So let's just do some examples, and hopefully it should make sense. So first up, we've got some degrees. So let's convert these degree measures into radian measures. Now, radians are unitless. So if this just said 325 and that's it, technically that would be in radians. It doesn't have the degree symbol on it. It doesn't have units, which means it's a radian. So keep that in mind. But 325 degrees, so to convert from degrees to radians, right, we're going to multiply by pi over 180. Okay, so we're going to take 325 times pi over 180. And again, this is where you want to be careful, because really that would give us 325 pi over 180 as our radians. And we can't just type that into our calculator, right? Normally we just type something in and simplify the fraction that way. But what you want to do is you kind of have two options. You can either simplify by hand, if you don't have a school calculator, if you're on Desmos, you can simplify this by hand by dividing both the numerator and the denominator by 5, right? So long as you do the same thing to the numerator, 180 divided by 5, to the denominator, can do it that way. Now that kind of requires you to know what factors they have, right? Sit here and think, okay, do 36 and 65 have any factors in common? The answer is no, but you could do it by hand. Another way you can do it, though, is if you type in 325 divided by 180 into your calculator and then hit that fraction to decimal button, so second PRB, it'll give you 65 over 36. Which would be our final answer here, right? We don't want to just type. You never want to do, 325 times pi divided by 180 and tell me that it's, 5.67 radians. Should never be a decimal. It should always be exact. So we never type pi into our calculator. If something, has pi here, we're leaving the pi there. Okay, so for 60 degrees, we would take 60 multiplied by pi over 180, which would be 60 pi over 180. You can see, they're both divisible by 10 for starters, which would leave you with 6 pi over 18, both divisible by 6 now, so divide both by 6, and we'll get pi over 3 as our final answer here. Okay, so when you're doing from degrees to radians, you kind of have to simplify the fractions by hand, or, just simplify the number part in your calculator. You cannot type the pi into your calculator. Okay, however, when we're doing radians to then degrees, I think it's a little easier, because if we start with negative 4 pi over 3, we multiply it by 180 over pi. Well, the pi's are going to cancel, and then it's just, negative 4 times 180 divided by 3. And that's something, it's all numbers, they're, all rational numbers. That's something you can just type into your calculator, and we will get that the answer is negative 240 degrees. Okay, we start here. 23 pi over 12. Well, we're going to multiply by 180 over pi. Here we go. Our pi's cancel, which leaves us with 23 times 180 divided by 12. And again, that's just something we can type into our calculator. And we get 23 times 180 divided by 12. That's going to give us 345 degrees, which should make sense, because remember, 2 pi, right? 2 pi is once around the circle completely. And if we're thinking in denominator of 12, 2 pi is the same as, that should be 24. 24 pi over 12, right? So 23 pi over 12 is almost a full rotation around the circle. 345 degrees is almost a full rotation around the circle. So we could kind of use that common knowledge we have about radians and about degrees to make sure, we punched it into our calculator first, or correctly, right? The first time I typed this into my calculator, I don't know what I accidentally typed in, but I got like 1.6. I was like, no way is 23 pi over 12 the same distance as 1.6 degrees. So kind of using our common knowledge to always make sure our answer makes sense. Okay, and that is actually all I have for this video. I think it's way more straightforward than maybe the other parts of this learning target. So I hope this helped. Again, if it didn't, there's lots of other videos online and resources online, but you can also always email me. So yeah,